Hi. We're going to talk a little bit about the material from lecture 23 today. That's the third lecture on hypothesis testing. As always, this video is not a substitute for reading the book and notes. There may be things in there that I don't go over that you need. Okay, this section is all about errors in hypothesis testing. We're going to start with an analogy. Suppose that some guy, a man, is on trial. Right? It's a criminal trial. There are two possible outcomes for this. Either the man is truly innocent. Right? So this is the true situation that I'm describing up here. The true situation is either that the man is innocent, or in fact, the man is truly guilty. Those are the possible true situations. Well, for each of those, there are two possible outcomes. We can either find the man innocent, right? That is, the jury can, or they can find the man guilty. And of course, they don't have to find him innocent just because he is innocent, or guilty just because he is guilty. It depends on the quality of the evidence. Okay, so if the man really is innocent and he is found innocent, that's good. That's a correct decision. If he is really guilty and he is found guilty, that is also a correct decision. But it can happen that he's innocent but found guilty. That's an error. And if he's guilty but found innocent, that's also an error. Now, in Western jurisprudence, ever since Roman times, we've had a thing called the presumption of innocence, which means that a defendant is considered innocent until he is proven guilty. It requires strong evidence to overcome the presumption of innocence. That's why we have that standard beyond a reasonable doubt in a criminal trial. The evidence has to be really strong. And so if we're going to translate this into the language of hypothesis testing, our null hypothesis, H0, has got to be that the man is innocent. And our alternative is then, of course, that the man is guilty. Okay, and then this table here turns into the following table. The true situation can be either that H0 is true or that H0 is false. Well, the hypothesis test can either fail to reject H0 or it can reject H0. And again, the test doesn't have to be right. It can make a mistake. Well, if H0 is true and we fail to reject it, in other words, accept it, that's good. If H0 is false and we reject it, that's also good. If H0 is true but we reject it anyway, that's called a type 1 error. If H0 is false but we fail to reject it, that's a type 2 error. Okay, let me rewrite those. A type 1 error is, here it is, H0 is true, but you reject it anyway. So we reject H0 even though H0 is true. Type 2 error, where's type 2? Right there. H0 is false, but we fail to reject it. So we fail to reject H0 even though, in fact, H0 is false. Often, though, we don't express the outcome of a hypothesis test in these errors in these terms. Right? I'm going to rewrite them in terms of what we accept. Right? We can think of a type 1 error as accepting the alternative hypothesis even though the alternative is false. So we've accepted something false there. A type 2 is that we accept the null hypothesis even though the null hypothesis is false. Okay, that's just, they say the same thing, but this is more often the language in which you want to express these errors. Let me say that these type 1 and type 2 errors don't occur because of human error, right? They occur because just as a jury can come to the wrong conclusion if it's given bad evidence, a hypothesis test can come to the wrong conclusion if it's given bad evidence. In the case of a hypothesis test on the mean, the evidence is a sample mean. Right? If you get a sample that is not representative of the population, its sample mean is probably not going to be very close to the population mean, right? And so your hypothesis test will conclude that the null hypothesis is wrong, even though in fact it's correct. Okay. If the null hypothesis is wrong, the same sort of thing can happen. You can get a sample that shows where the mean is close to the population mean, and fail to reject. It can happen, and it can happen purely through random chance. It's not a matter of error. Okay, let's do some examples. We'll start with this one. You are in charge of drug testing for your company. Write in words null and alternative hypotheses suitable for showing the presence of a drug, and describe the practical consequences of making type 1 and type 2 errors. Okay. Now, your job here, it says, is to design a test to show the presence of a drug. So that is what you want. We don't have any X bar or anything like that. All we have is your preference. So we're going to take as our alternative hypothesis that a drug is present. And our null hypothesis is, of course, that a drug is not present. Okay, a type 1 error means to reject the null even though it's true, or accept the alternative even though it's false. Now I'm going to phrase this in terms of the alternative, in terms of what we accept. So it would be something like to find that a drug is present even though in fact no drug is present. A type 2 error, we accept the null hypothesis excuse me even though it's false. So let's say that. Right? The type 2 error would be to find that a drug is not present even though in fact a drug is present. Okay, let's do another one. A regulation requires an average bacteria count mu of 70 as the maximum acceptable for fishing waters. If the average is above 70, the site is considered unsafe and is closed. So, suppose that you work for the agency which monitors these waters, and you are interested in showing that they are unsafe. Write appropriate null and alternative hypotheses for testing these waters. Okay, so what you want to do is show that they're unsafe. So your alternative hypothesis is going to be waters are unsafe, right? And that is mu is greater than 70, because that's what makes the waters unsafe. And then the ho is going to be mu less than or equal to 70. Right? In other words, the waters are safe. Okay, describe the practical consequences of making type 1 and type 2 errors in this situation. Well, a type 1 error, right, we're going to accept the ha even though it's false. So we would find the waters unsafe, right? That's what accepting the ha would mean. Find the waters unsafe even though they are safe. And the type 2 error would just be the other sort of thing. Right? The type 2 error is to accept the ho even though it's false, so we would find the waters safe even though they are unsafe. And that's about all